Good morning, class. Today we are on Saxon Book 4, Lesson 55, and we'll be talking about prime and composite numbers. So, to start with, we're going to talk about two different vocabulary words, and I need you to put these in your math dictionary so that you've got them for future reference. So the first one is multiples. A multiple is a number that you say when you're skip counting. So let's say I'm counting by twos. I'm going to say 2, 4, 6, 8, 10. All of those are multiples of 2. I could count by 3 and say 3, 6, 9, 12. Those are all multiples of 3. I could count by tens, 10, 20, 30, 40. Those are multiples of 10. So you'll see this word in your textbook throughout the rest of this year and in your next couple years of Saxon math as well. Multiples, those are the numbers that we say when we're skip counting. So I've got that here for you. You can get that down in your math notebook. And then the other number that goes with that is factors. And a factor is two of the numbers that make up a multiplication problem. So we take a factor times a factor, and that's going to give us a product, which is the answer to our multiplication problem. So we might have 4 times 3 equals 12, where 4 is a factor and 3 is a factor. And what we would say is 4 and 3 are factors of 12, meaning we can multiply them together to equal 12. All right, so I have a couple of examples we're going to talk about. This would be a good place to pause, get this stuff in your math notebook, and then hit play when you're ready to rejoin me. All right, so our first example says list the first 4 multiples of 7. So we start with 7, 14, 21, 28. 4 multiples of 7, we are just counting by sevens. 7, 14, 21, 28. So the second example says, what is the 4th multiple of 6? We're looking for the 4th multiple of 6. So there's 2 ways we could do this. We could count by 6, just like we did with the 7 problem before. So let's do that first. We'd say 6, 12, 18, 24. That's my 4th multiple of 6 is going to be 24. The second way we could do this is just say, well, gee, what is 6 times 4? And that's going to give me the 4th multiple of 6. 6 times 4 is 24. 24 is my answer. The next one said, what's the 3rd multiple of 8? So we're looking at multiples of 8, and I want the 3rd multiple of 8. So 8 times 3. Maybe I don't have this one memorized, so I have to count by 8s. 8, 16, 24. 24 is also a multiple of 8. Okay, our next one changes up how they ask a little bit. It says 12 is a multiple of which whole numbers? 12 is a multiple of which whole numbers? So we're thinking of whole numbers. Whole numbers are the numbers that we say when we count by ones. And which of those numbers, if we count by, can we hit 12? Well, 1. If we count by 1, are we going to say 12? Yes, absolutely. 12 is a multiple of 1. If I count by 2, am I going to say 12? 2, 4, 6, 8, 10, 12. Yes. 12 is a multiple of 2. If I count by 3, 3, 6, 9, 12. Yes. If I count by 4, 4, 8, 12. What if I count by 5? 5, 10, 15. Am I going to say 12 if I count by 5s? No. What if I count by 6? 6, 12. 12 is a multiple of 6. What about 7? 7, 14. Will I say 12? No. 8, 8, 16. Will I say 12? No. 9. If you're saying, Mrs. Duarte, I think that's all there is, you're absolutely right. These are all factors of 12, which means 12 is a multiple of each of these numbers. So here's how we write it. If they had written that problem a little bit differently and said, find the factors of 12, we're looking for multiplication problems that equal 12. So again, I would start with 1. Oh, you know what? Ha 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 ha. We missed 1. I forgot because I stopped at 9. I didn't make it the whole way to 12. If I count by 12s, do I say 12? Yeah, absolutely. That's the first number I say. So 1 and 12 are factors of 12. 2, what do we multiply by 2 to get 12? 2 times 6. What do we multiply times 3 to get 12? 3 times 4. And then that's it, because now if we keep counting, we'd write 4 times 3, but we already have that one. We would write 6 times 2, but we already have that one. And we'd write 12 times 1, but here it is, okay? So to find factors, you're trying to think what multiplication problems equal the number that I'm trying to find the factors of. To find multiples, you just count by those numbers, whatever number is given, okay? So, if you are in my class, we are going to do the activity on page 353 when I see you in class this week. You will need some kind of manipulatives like we had last week. Some people use Cheerios or candy or whatever they had around the house. Counters of some sort when I see you in class, okay? If you are not in my class, then I highly suggest you open the book to page 353 and do the activity that is listed there as well so that you can deepen your understanding of factors and, factors and multiples. So, couple more examples that we're going to do before I let you go to do your homework, and we still have to talk about these words up here, prime and composite. So my next example is list the 4 factors of 6. 4 factors of 6. So we're looking for what times what equals 6. Well, I always start with that one. It's the easiest. 1 times 6 is going to equal 6. What about 2? 2 times 3 is going to equal 6. What about 3? Hey, I've already got it there, so I don't need to list it again. 4? 4 times what equals 6? Can't do that one. 5? Can't do that one. And I already have 6. So this is it. Now the book said list the 4 factors of 6. So once you got here, you could have said, oh, I have them all. So they want them in a list. So let me show you a different way to do this. Oftentimes, you'll start with 1, and then you give yourself a little bit of space, and you can put 6 at the end. In this case, I know there's only 4, so I don't need a whole ton of space. If I had a number like, say, 24, that has a lot of factors. I would need more space to write them all out. But in this case, the question told me there's 4 factors of 6. So I have 1, I have 6. I have 2, and I think 2 times what equals 6? 2 times 3. And then I just put a comma there, and here I have them all in a list. Okay, the next one says, list the factors of 9. So I'm going to change that out just a little bit. And we know that 1 times 9 equals 9. Let's do this in our list fashion. So I have 1, and then over here I'll put my 9. 2. 2 times what equals 9? Can't do it. It's not a whole number. What about 3? 3 times what equals 9? 3 times 3. I don't have to write the 3 twice because I already have it. 1 is a factor of 9. 3 is a factor of 9. What about 4? No, I can't multiply anything times 4 to get 9. 5? No. 6? No. 7? No. 8? No. And we already have 9. So there are only 3 factors of 9. And the last one before we talk about these words says list the factors of 7. So I know 1 and 7 is a factor. So I put my 1, I put my 7. What about 2 times 7? Not times 7. 2 times what equals 7? Can't do it. 3 times what equals 7? Can't do that one either. 4? No. 5? No. 6? No. So 7 is a special number that only has 2 factors, and we call those special numbers prime numbers. A prime number is a number where the only factors are 1 and itself, such as in 7. 3 is a prime number. 2 is a prime number. What about 4? We have 1 times 4, or we have 2 times 2. So 4 is not a prime number. What about 5? 1 times 5. Can we multiply anything else to get 5? No. So 5 is a prime number. 6? 1 times 6, or 2 times 3. 6 is not a prime number. 7, we've already said, is a prime number. 8. 1 times 8, or 2 times 4. Are you noticing something about those even numbers? Even numbers always have a factor of 2. So most even numbers, in fact, all even numbers except the number 2 are not prime numbers. So what's it called if it's not a prime number? That's where this word comes into play. Numbers that are not prime are called composite numbers. If they have more than 2 factors, they are a composite number. So all even numbers except 2 are composite numbers. 2 is a prime number because its only factors are 1 and 2. So 2's our only even prime number. It looks like all odd numbers are prime at the beginning because we look at 1, 3, 5, 7. But remember, we just did 9. 9 is an odd number. Is 9 a prime number? What were the factors of 9? It was 1, 3, and 9. So that's not a prime number because they have more than 2 factors. That 3 throws a wrench into it. So while most numbers that are odd, most numbers that are prime are odd, not all odd numbers are prime. I'm going to say that again because it's a little bit confusing. Most prime numbers are odd, all of them except 2. However, just because you're looking at an odd number does not make it a prime number. 9 is not a prime number. Another example would be 15. 15 is not a prime number because we can do 3 times 5 to get 15. All right, so my very last example that I'm going to give you is which of these numbers is prime? I'll put a couple up on the board. We've got 8, 9, 10, and 11. Which of these is prime? Well, I remember my teacher said a prime number is a number that you can only multiply 1 times itself to get the answer. So I'm going to look at these and say, can I multiply anything times 2 to get the answer? Here I can. 2 times 4 is 8, so I know this one's not prime. 2 times 5 is 10. I know this one's not prime. 2 times something equals 9. Can't do it. 2 times something equals 11. Can't do that either. So then I think 3. Can I do 3 times something to get 9? Yes, 3 times 3. So this one's not prime. So that tells me this is my answer. 11 is a prime number. Okay. You have a lesson practice assignment to do. It begins on page 355. I want you to do your lesson practice and then check your answers in the answer key that you've been provided with. We're not going to go over the lesson practice in class this week. However, if you had trouble with these prime and composite numbers, I do want you to get online and say, Mrs. Duarte, I need some help. Can you schedule some time to meet with me? Okay? Once again, that's on page 355. And when you finish and check your lesson practice, you can start your homework, which begins on page 356. Hope you have a wonderful day, and I'll see you soon.